This is one of the largest webinar that we have on autonomous vehicles and with the most attendees. So thank you for joining today. It's a very special one. Today we will have Ken Moshi from Transport Canada, and today's topic is preparing for connected and automated vehicles in Canada. I'm your host. My name is Fahad Shuja, and I am with the Member and Technical Services at Ontario Good Roads Association. For those of you who may not know, Ontario Good Roads Association is a not-for-profit, and we have been established since 1894, and it's been 123 years. What we have done since then is that we have a number of departments within Ontario Good Roads that do wonderful stuff. We do education, training. We have an advocacy arm. We also have member technical services. That's where I'm from. And we also hold a large annual conference that just finished a few weeks ago at the end of February. And there's tons more. So if you want to go to ogra.org, you can get more information on that. If you look at the DNA of OGRA, we began 1894, and this was the time when the transportation system was moving from horses to vehicles. We see that similar trend now that we're in the era of moving from manual drive to truly automated vehicles. So it feels right for OGRA to be in this autonomous vehicles arena. What we have done is that about a year or 2 years ago, we put out a white paper called the Roadmap for Autonomous Vehicles in Ontario, and you can find that on the OGRA website. Also, what we have done is that we have created something called MACAVO, so Municipal Alliance for Connected and Autonomous Vehicles in Ontario. Some of you are probably members of it already. What this team is working on right now, or starting to work on, is a very special project. And this is an initiative driven by OGRA. And the intention is to create a Windsor-Ottawa municipal corridor to allow for testing of level 4 and 5 autonomous vehicles. But today's topic is not about that, so we'll give you more updates on that soon. This, what you're attending right now is a series of one of the series of webinars, and our intention is to bring forward to you subject matter experts straight to your screen. And as the presentation goes on today, you can post your questions at any time, and Ken will be able to address them at the end. Just to tell you a little bit about Ken, he joined the Federal Public Service in 2008 as an analyst with Natural Resources Canada's Fuel Policy and Program Division. Ken provided insight and analysis to senior managers on biofuels, CNG, LNG, electric vehicles, and other alternate transportation fuels and vehicles. In 2015, Ken joined Transport Canada's program group and led the development of the program to advance connectivity and automation in the transportation system, which is ACATS. So the ACATS program was launched in June of 2017 and is to help prepare Canada for a wider use of connected and automated vehicle technologies. Ken's current responsibilities include supporting the delivery of the ACATS program, as well as the participating on projects, studies, and analyses relating to connectivity, automation, and cybersecurity in road transportation. So with that, I would like to turn it to Ken.
Okay, thank you very much, Fahad. Thank you for the invitation, and thank you to the OGRA members who are on the line today. Look forward to giving you this presentation and to answering any questions that you may have. But before we begin, I think, I'd like to take a quick moment to acknowledge the reported fatality with the automated vehicle in Phoenix. I don't have, and I'm not giving you, and this is important, I'm not giving you an official Transport Canada position or statement, and I don't have any more information than what's been reported. But given the subject of the presentation and why everybody's on the line today, I have no doubt that it's on everyone's mind. I think the reality is, there are too many fatalities on our roads. 37,000 fatalities in the US in 2016, 1,800 in Canada in 2015, over 150,000 injuries. That's too many. And so this is another fatality that we certainly want to see avoided. And although we don't hear about most of the fatalities on our roads, we certainly will be hearing about every collision involving, vehicles that display and that enable higher levels of automation for the foreseeable future. Advanced vehicle technologies like higher levels of automation, they will be a big part of the progress towards reducing fatalities. Canada, we've adopted a road safety strategy, so Road Safety Strategy 2025, with a Vision Zero element. So I think that was adopted through the Canadian Council of Motor Transport Administrators. It's a national vision. It's a national desire to see a true downward trend in fatalities and injuries on our roads. We have to remember that these technologies ultimately are still under development, and so in the context of on-road testing, especially when we get into testing without a safety backup, without someone at the wheel, we have to really try to understand the acceptable level of risk, not just for the occupants, but also for our road users. But ultimately, these technologies and other technologies will lead to reductions in collisions, in fatalities and injuries, and that's what we're working towards. Certainly, our thoughts are with the families of yesterday's victims, as well as all other victims of road fatalities. So with that, I'll get into the outline of the presentation. So we'll, very quickly go over some of the key concepts around connected and automated vehicle. I won't spend too much time on those because I imagine that most on the line are fairly familiar, certainly with the automated vehicle. Perhaps the connected a little less so. It's easy to try to mix the two together, and so we'll talk a little bit about that. We'll get into a little bit about commercialization timelines for some of these technologies. We'll spend some time on some of the challenges to connected and automated vehicle deployment. Then we'll get into the program to advance connectivity and automation of the transportation system, which is the one that Fahad mentioned. So that's our ACATS program, and leave with some final thoughts and then open up for questions. So, very briefly, when we talk about connected vehicles, for the most part, right, we're talking about communications between vehicles that enable safety or efficiency benefits. So vehicle-to-vehicle communications, where there's in this case, a basic safety message. So a set of very specific information that's communicated at a rate of 10 times per second on current speed, current heading for a particular vehicle. Other vehicles could take that information and based on that and other sensor data can decide whether or not to issue some kind of warning to the driver to take some kind of evasive maneuver or to avoid a particular action. Supporting connected vehicles, we're calling it smart roadway infrastructure, smart infrastructure, that's connecting, traffic infrastructure such as traffic lights, allowing them to then communicate signal phase and timing, or connecting information such as road weather, current road conditions to communications technology, and allowing that information to be communicated to vehicles. So a vehicle could take the information and go, oh my, the current state of the road right now, it could be slippery, but it is slippery. There is black ice right now. Or other information such as issuing a curve speed warning for the conditions of the road and the speed of my vehicle. I'm going too fast for this particular curve. I better slow down, say for a highway off-ramp. The last piece, of course, is automated vehicles, that are using onboard sensors, potentially connectivity to take over one or more driving functions. And we've had partial automation for quite some time. Think your cruise control. Full automation, that's what we're driving towards, where eventually there is no driver, so to speak. There are only occupants. Certainly, folks would have seen this, the SAE levels of automation from level 0, where there is no automation, the driver is fully responsible, must take all action, to level 5, full automation. Basically, it's an occupant. The vehicle can handle all range of driving conditions, and then there's the tricky in betweens, where there's a few levels where the driver must be present, must be aware of the current driving conditions, must be ready to take control. Where and then as you get higher up, where the the vehicle can really handle most of the driving, but in specific conditions. Ultimately, I think we tend to see a convergence of connectivity and automation, connected vehicles and automated vehicles. What an automated vehicle can do without having additional information coming in. In other words, what an automated vehicle can do based on the range of its onboard sensors. We think by adding in that layer of connectivity, you increase and improve the situational awareness of the vehicle. So what can be done without connectivity can be done much better with connectivity. In terms of some of the timelines, so a lot of the connected vehicle work certainly is being driven, certainly for North America, it's being driven by the U.S., the National Highway Traffic Safety Administration, or NHTSA, which issues motor vehicle safety standards. A standard was proposed, was issued last year, I believe, and it would apply to light-duty vehicles and, light-duty vehicles as of a certain model year. At the time it was as early as 2021, remains to be seen, what will happen with that proposed regulatory requirement. Nevertheless, you would see a phase-in period where all new light-duty vehicles would have to be able to communicate with each other. And certainly there is one model, vehicle that is available on the road today. It happens to be a GM Cadillac CTS that comes standard with V2V technology. It's the only one that I'm aware of at this time that's available. In terms of automated vehicles, well, levels 1 and 2, so from cruise control to adaptive cruise control with lane keeping, lane centering, and those sorts of technology that's already available on our roads. Level 3, so this is where again it's conditional automation where the driver must be ready to take over, but the vehicle can handle a specific environment on its own. Availability was announced for model year 2018, so this year. Level 4, possible availability, commercial availability as a ride-hailing service in Phoenix, Arizona, and we'll talk about these in a little bit more depth on the next slide. Level 5, I know that there's a lot of marketing out there that's suggesting maybe in the next couple of years. Personally, I don't see that. Level 5 is a vehicle that can handle basically any driving condition, any driving situation, and there's a lot that human drivers can do in terms of anticipating, in terms of understanding the unknown, in terms of communicating with other drivers, in terms of reacting to rapidly changing conditions, driving through construction zones, all these sorts of things that are actually kind of tricky for computers to deal with. So I think we're still quite a ways away from true level 5. In the context of automated vehicles, it's really important to talk about the operational design domain, and you can see the definition that's provided by NHTSA on ODD. But ultimately, it's the real specifics around under what range of conditions can this higher level of automation, can this system be used. So if we talk about the level 3. In this case, it's specifically, again, this is the only one I'm aware of, it's the Audi A8, and you can see what are some of the conditions under which, the level 3 automated driving system will be able to take over or can function properly. So you can imagine that, middle of a city center that, that's not going to function, right? Because there's no traffic lights, no pedestrians. When we get to level 4, so this is, of course, Waymo's safety assessment. Their vehicles are designed to operate in inclement weather, such as light to moderate rain, and can operate in daytime and night, which is certainly very impressive. It's also very much geofenced to a specific area in Phoenix, Arizona, that's been mapped to perhaps centimeter level accuracy. And I'm raising this really to say that there's still a ways to go before these vehicles are truly ready for prime time. And I think we're let's talk about some of those challenges right now. You know, one of them really is the technology, you know, the performance of the technology. You know, a lot of the AV systems are based on some form of ultrasound, LiDAR, radar, cameras. You know, cameras that are you know, these vision-based systems to recognize objects. They don't work well when the cameras themselves are covered in snow, or when the objects are covered in snow, or when the cameras are, you know, entering or exiting, let's say tunnels, and there are extreme light changes, you know, blinding by the sun. So they don't work as well. LiDAR doesn't work so well in rain and snow. So there will be a collection, you know, of different sensors, and the data has to be fused. But nevertheless, you know, we're seeing that many ADAS systems, advanced driver assistance systems, such as lane keeping, such as pedestrian detection, some of these technologies that we are testing in Canada that are commercially available, they're not functioning, you know, as well as they would need to in the context of, you know, fully automated vehicles. So there's still some work to be done in terms of proving out and testing the technology. You know, I'm going to steal a couple of messages, or points that were made by the heads of research from Nissan. This was at the Automated Vehicle Symposium a couple of years ago, and at Toyota, who spoke at the Canadian Institute of Transportation Engineers Conference in 2017. Things like, the cultural aspect to, engaging with road users, with pedestrians, anticipating pedestrian behavior, the communication, the silent communication between drivers and road users, such as when, two vehicles arrive at a four-way stop and one driver looks at the other driver and goes, okay, you go first, or I'll go first, or whatever, that kind of communication. That's not easy for a computer to deal with, to make out. If the traffic light says one thing but the police officer says another, a human driver knows what to do. An automated vehicle, perhaps not so much, right? Because it's getting a conflicting message, and it's potentially a risky maneuver to proceed through the intersection even if the light is red. And how does it know that it should trust the police officer? So all these cultural aspects, to the social aspects, I should say, to navigating our roads are still really tricky for machines. But by no means will we not get there, but they're tricky. Interoperability is another issue. So, to the extent that there will be connected vehicles, it'll be important that these vehicles are able to communicate with each other regardless of what jurisdiction they come from. So whether these vehicles, are from the States and come up to Canada, these vehicles should be able to communicate with our infrastructure, with other vehicles, likewise, across Canada. So there needs to be, work, and there is work being done in terms of making sure that the standards are in place and certifications are in place for these for connected vehicles, for roadside units to communicate with the vehicles. Right now there are some certifications out there, from the Radio Spectrum Regulator, which is Innovation, Science and Economic Development Canada, ISED, around the V2V devices, but there's no certification right now for roadside equipment to communicate with connected vehicles. And what we've heard from several jurisdictions in the States in particular that have been working on the vehicle to infrastructure communication piece is that it's not plug and play. It's not as simple as just buying a roadside unit and hanging it up. So work needs to happen to support interoperability, to encourage that deployment of ICT and smart infrastructure. I'll jump to that one for a second. There's also questions around, who pays for all of this? Who pays for the communications equipment? And for that matter, which communications equipment? There's no doubt a lot of conflicting information if you're following some of the discussions around dedicated short-range communications versus other forms of communication such as cellular V2X, or in the future into the 2020s, 5G. And so I have no doubt that it's a challenge for many road authorities to decide, well, if we invest in one type of communications infrastructure, will it be obsolete in 2 years? If we talk about, the availability of HQP, we're seeing that, things like cybersecurity, managing large amounts of data, these are challenging the traditional, I think, transportation engineering disciplines. So there's a lot more of an emphasis on data, on computer engineering, software architecture, all this stuff that we need and road authorities will need in order to better manage the transportation network. Driver education is another important piece. We need to educate drivers on the safe use of some of these systems. When I started taking my driving lessons many years ago, anti-lock braking systems had been a requirement for several years, and so we were still in this kind of transition period where some people didn't have them, newer vehicles did, and I remember being taught, well, with an ABS system, you don't pump the brake like your parents might be doing in their vehicle. You hit the brake hard. Well, it's the same thing with advanced driver assistance systems, understanding the difference between lane keeping and lane centering and under what conditions it might and might not work, understanding the real important distinction between, being able to enable a level 2 system and being able to, and an over-reliance on it is really important. So that education piece needs to, we really need to work on that one. Traffic enforcement, no doubt, what happened in Phoenix is really gonna, perhaps uncover a lot of the questions that some of the people have been asking, and how is law enforcement going to deal with that particular collisions and with future collisions where the vehicles are operating within their design domain and there is a collision right now. Now, who's at fault and how to address that? So, all this to say, there are many challenges. No single entity has has all of the answers or full responsibility to find all the answers. This will be a theme that you'll find through this presentation. Ultimately, we have to work together to try to address some of these challenges, and really none of them are insurmountable. Ultimately, the impacts of automated vehicles in particular are unknown. I like this particular infographic, which was put together by the U.S. Department of Energy. They had done a study, looking out to 2050. What are the potential energy increases, or what are the potential ramifications on energy use in transportation? Relating to everything from population growth to travel demand to, of course, vehicle technologies. And when they put everything together, well, either there's a 200% increase in energy consumption or there's a 60% decrease in energy consumption. Who knows? A lot of it relating to, what the deployment of automated vehicles, the commercialization timeframes, whether or not we're able to reduce vehicles in size because they're much safer, and all of these types of variables. But the point is, there are many unknowns, and no one institution, no one group has the answers. But I think ultimately our goals are shared. We're all looking at improving safety, improving efficiency, improving the sustainability of transportation, making it more accessible, and helping citizens become more mobile. So how do we address some of these challenges, and what are some of the work that we're doing or involved with in addressing some of the challenges? The first one is a cooperative truck platooning system. So truck platooning is when, or platooning in general is when multiple vehicles, typically 2 or 3, follow each other at a very close range, and they're able to do so because of some form of automation. The following trucks are not quite in control of all aspects of the driving system. So in October 2016, we working with University of California, Berkeley, Volvo Trucks, USDOT, the National Research Council of Canada. We brought over an experimental 3-truck platooning system that was developed by UC Berkeley and tested it out at the Motor Vehicle Test Center in Blainville, Quebec, to try to understand what are the potential fuel economy benefits. And for a range of test conditions that were examined, which included using aerodynamic treatments, the net savings for the fuel platoon was between 5.2% and 7.8%. The combined effect of platooning and aerodynamic trailer devices was measured up to 14.2% at a separation distance of about 17 meters, which is 57 feet. In August of 2017, we brought those vehicles back to do another suite of testing. The separation distance was shrunk even more to a matter of I think 3 or 4 meters between the trailer in front and the truck in back at about 80 kilometers an hour. So that report is going to be, the phase 2 report should be published and should be publicly available in summer 2018. On the interoperability side, the IPS architecture, I imagine some of you would be familiar with it. It's a common framework for planning, defining, and integrating ITS deployments. It certainly would be an important part of any type of connected vehicle and communications infrastructure between vehicles and road transportation infrastructure. It was developed and it was aligned in the early 2000s with the U.S. architecture. That stopped being the case about 10 years ago as the U.S. has continued to develop its architecture. They also developed a separate architecture just for connected vehicles, put it all together, and I think mid last year they released their architecture called Architecture Reference for Cooperative and Intelligent Transportation, ARC-IT version 8. We did we participated in a stakeholder outreach project with the Transportation Association of Canada. It was a survey of Canadian stakeholders to determine if there was a need and interest in updating the architecture and in maintaining that alignment with the U.S. Unsurprisingly, the results were very favorable, and there was interest for continuing, support or reestablishing, in fairness, support for the architecture and bringing it back up into alignment with the American version. And so that is a project that we'll be undertaking next fiscal year. On the cybersecurity, privacy and trust aspect, I mean, the reality is, as vehicles become increasingly reliant on electronic control, as vehicles continue to have more forms of connectivity, whether it's Bluetooth, whether it's communications through the TPMS, the tire pressure monitoring systems, whether it's the vehicle-to-vehicle communication, whether it's through the cell for the infotainment, whatever it is, increasing connectivity, increasing electronic control, increasing automation. Now you're increasing the potential for vulnerabilities, but also the risk of any potential cyber attack. So we've been working with a few other departments in Canada and our colleagues at the US DOT on some vulnerability assessments relating to vehicles, light, medium, and heavy-duty vehicles. There's also an important aspect to privacy and trust around connected vehicles. The idea being, if my vehicle is broadcasting information about its current location, current heading, current speed, 10 times per second, is that not a way to track it and to remotely track my movements? So in the U.S., as part of the whole connected vehicle work, they've put forward something called the Security Credential Management System, in part to address the privacy of individual drivers. In other words, to ensure that vehicles cannot be tracked using the V2V system. And at the same time, this SCMS is to ensure authentication of and trust in all of the communications between vehicles. In other words, if a vehicle is sending out information and another vehicle receives it, how does that second vehicle know it can trust the information is coming unaltered and from a reliable source? So the security credential management system is something that's been under development in the States for quite some time. There is a prototype that's being launched to support the large-scale connected vehicle pilots in the States in Tampa, Wyoming, and New York City. And we've done a little bit of initial scoping on, okay, so what does that mean for Canada? How do we ensure that Canadian vehicles are trusted in the States? How do we ensure that U.S. vehicles are trusted here? How do we ensure that regardless, if there are misbehaving devices, if there are devices that should not be listened to because they're sending out incorrect information maliciously or because they're broken, how do we tell all the other vehicles to ignore the information coming from those misbehaving or malicious devices? So we will be continuing to do some work in that space, very closely with our American counterparts. Another aspect that we really are going to get started on, and this is through the ACATS program, is looking at road transportation infrastructure cybersecurity. There's a lot of work going on in terms of vehicle cybersecurity, everything from challenges and hackathons from university level and up to try to do vulnerability assessments or penetration testing on vehicle systems. There's information sharing mechanisms, again led by the U.S. the Auto ISAC, Information Sharing and Analysis Center. It's basically all of the major vehicle manufacturers that have set up a system whereby they can share vulnerability information, threat information. So, the vehicle side of things seems to be, progressing well. There's been guidance developed by multiple governments. SAE is doing a lot of work. We want to make sure that the road infrastructure side of things is equally well covered. So we're going to be, supporting some work in that space. One project I will just mention is a Transportation Research Board, TRB project, on the cybersecurity of traffic management systems. They're looking to ultimately develop a suite of best practices to improving, the cybersecurity of TMS. I appreciate this may not be a clickable link on your screens, but if you look that up, you're sure to find it. And then the first report, the first deliverable, which is a literature review, was released in January, and it's available online on the TRB website. Continuing with some of the work we're doing here, and I alluded a little bit to it, we have a testing program where we test here at Transport Canada, where we test, advanced vehicle technologies, where, and where we test vehicles in terms of, for collision avoidance systems, crash worthiness, and, we work with other governments, and we share knowledge with governments, with industry, to ultimately, improve or lead to improvements in some of these systems. One new piece of work that's currently under development are some safety guidelines that my colleagues are working on for industry in terms of, the safe design and deployment of automated vehicles. So this is something that's recently been started, and it's very much targeted at industry. There are some guidance that are being developed more for road authorities, and I'll get to those in just a moment. But we do work with road authorities through the Council of Ministers responsible for transportation and highway safety. There are some resources that have been developed there through the Policy and Planning Support Committee around some actions that should be taken to address, some of the challenges they identified relating to the deployment of connected and automated vehicles. The Canadian Council of Motor Transport Administrators, CCMTA, is developing some guidelines, which I'll talk about in a sec. And then finally, this would probably be of most relevance to OGRA members, which is the Transportation Association of Canada. We participate on a working group relating to connected and automated vehicles, and that group is being upgraded to a task force, which is a really great thing to see, because it recognizes the cross-cutting aspects to connected and automated vehicles. So the AV testing and trial guidelines, two things that we're supporting or working with provinces and territories, in both cases through the CCMTA, the Canadian Council of Motor Transport Administrators. The first is, our guidelines that are more geared towards organizations that wish to test AV technologies in Canada. So it would clarify some of those regulatory requirements, such as importing, licensing, that would need to be followed to conduct those trials. It would also recommend a baseline of safety practices that organizations should follow when running their trials. At the same time, so some consultations on these guidelines will be undertaken in spring, summer 2018. We're also working with CCMTA. In fact, they're leading this one. So these are guidelines that road authorities and jurisdictions can use to develop their own regulations and policies regarding the testing and deployment of automated vehicles. And so again, that would look at things like licensing and driver training and reporting. So the first is more geared at organizations. The second set of guidelines are more geared towards road authorities. And consultations on these guidelines will be undertaken in spring 2018. We're also supporting technical work, around better understanding some of these technologies. So by now, I hope everyone will have heard of the active Aurora connected vehicle test beds, which are located in Edmonton, Alberta, and in Vancouver, BC. There are basically three small test beds in the Edmonton area and one small one in Vancouver. The Edmonton test beds and so the University of Alberta, the active work is really focused on the connected vehicle applications. So all of this data is coming in. What can we do? What kind of applications can be enabled from the data? So, for example, it could be improved, real-time speed recommendations. So rather than the speed limit being 50 and vehicles engaging more in a stop-start scenario, they would be more, a recommended speed might be 40 kilometers an hour, and that enables a more smooth flow. Road weather information is another one. Queue warnings, I think, is another one, so backups. Ontario, there's the Commercial Vehicle Eco-Driving Pilot Project. So that's a one-year initiative that's running along a 6-kilometer stretch of Hunt Club Road in Ottawa. It has 12 connected traffic signals that are communicating, that are able to broadcast signal phase and timing. They communicate with some partners to the project that are operating freight and delivery trucks, and to help them determine optimum speeds and reduce fuel consumption and avoid hard braking. So we've contributed to that. And then the last one is some vehicle cybersecurity work that's being led by Carleton University with BlackBerry QNX. They received some funding from Defense R&D Canada, and we are participating on that project. The last piece is the the Regulatory Cooperation Council. Just want to kind of give a shout out to that. That's really been a great way to work with our U.S. colleagues to address many of the issues relating to connected vehicles, and some of them, you could argue also apply, like cybersecurity, to automated vehicles. And you'll see that many of the four themes, many of these are things that I've already talked about as some of the challenges. So now to quickly talk about our program to advance connectivity and automation in the transportation system, our ACATS. Budget 2017, so this would have been last year, announced some funding for some innovative technologies around connected vehicles, automated vehicles, and unmanned aerial vehicles. So there was $50 million put towards that. And from there, we get our ACATS program, which is really aimed at helping Canadian jurisdictions prepare for, many of the issues relating to, connected vehicles, automated vehicles, higher levels of connectivity, higher levels of automation. So we got a portion of that $50 million, and you can see the key activities right there. But basically, we're a modest program that's really trying to leverage some of the really smart people who are doing some amazing work in Canada, leverage some of the knowledge and try to, make it available to others, provide a little bit of funding to undertake research and studies in areas that are, deemed, important and where a bit of help is needed. The vision in a way for the program is that we're better prepared for the safe and secure deployment of, advanced connectivity and automation in transportation. We want to see ourselves as supporting capacity building, but also being a bit of an information clearinghouse for a lot of the really good work that's taking place, and that in some cases just needs a little bit of financial support to be undertaken. We have 4 pillars to our program. Connectivity, automation, cybersecurity, and digital infrastructure. That one we mean by digital infrastructure, we mean a little less the ICT infrastructure and a little bit more the data that is underpinning the delivery of a road transportation, a modern and robust 21st century transportation system. I mean, ultimately, you can't do, we can no longer just worry about roads and traffic lights. We need to worry about and address, the data piece, worry about the ones and the zeros, the bits and the bytes as much, the digital infrastructure as we do the physical infrastructure. So we see, 3 areas of work: the development of HQP, ensuring that road authorities have the appropriate, resources that they need to support, advanced connectivity and automation, and making sure that there is an opportunity to really test and evaluate, these new technologies. Ultimately, Transport Canada does not own roads, does not manage the delivery of road transportation services, and so by no means are we going to tell municipalities and provinces, what to do and how to do it. But what we want to do is we want to say, hey, there's some really great ideas going on in these areas. Maybe we can take some of the learnings and bring them elsewhere, whether those great learnings are, outside of Canada or within Canada, whether, we want to make that information available to others where a bit of help is needed to support, pooled fund projects. We want to do that. We want to be there. Our primary stakeholder is and continues to be road authorities. Quickly mention this report. I imagine most people would have seen it. It was over the past year and change. The Senate Standing Committee on Transport and Communications has called a number of witnesses around understanding some of the technical policy and regulatory issues relating to connected and automated vehicles. There are 16 recommendations. You can find the report on the Senate website. The only thing I will say is that this of course requires a government response, and that is due later this summer, and it will be made. Once I guess it's been accepted by the committee, it will be made publicly available. So what does this mean for OGRA? I mean, the 21st century transportation system, it's connected, it's automated, it's data driven. At the same time, though, mixed fleets, so that's, some vehicles have higher levels of automation, others do not. That's the reality for the near and foreseeable future. It's one thing to have, designated areas where there's only automated vehicles and, far fewer interactions with, anything else. Then, it's a much simpler ODD, operational design domain, than one or environment where the vehicle is operating than one where there are mixed fleets and different levels of automation and pedestrians and cyclists. And so that is a challenge. There's a growing interdependency of vehicles and infrastructure that really wasn't there before. But vehicles will be dependent on information received from infrastructure, and infrastructure, traffic signal systems can improve, timing, for example, based on real-time data coming from vehicles. Ultimately, it's road authorities that own the infrastructure and operation pieces, and we don't have the answers, but we certainly want to work with stakeholders to find solutions. So with that, thank you very much, and I'm happy to take your questions.
Okay, thank you so much, Ken. That was an excellent presentation. You covered a lot of good points, and it's really good to see the support that Ontario and Canada is getting when it comes to AVs. So thank you once again. We do have a few questions, and I can just let me see how much time we have. Okay, we have about 10 minutes, so I have about 3 or 4 questions in line already. If you're listening to this, please post your questions up, and we will take them as time permits. So, Ken, the first question is: are AVs able to acknowledge temporary road closure signs?
That's a perfect question. Are AVs able to acknowledge those? So then it all depends. I don't know. I don't have any of the information, let's say, on the Audi, right? So let's talk about that one, because they've said, it will be commercially available. The A8 will have that level 3 automation. So I don't know. Will it be able to handle that? Or will the vehicle say, something's weird, driver, wait, come back into the loop. You've got 10 seconds, you've got to take over because something strange is happening here. So they may acknowledge that there's a problem. They're approaching a situation that they don't understand. One would hope that when you're at level 4, one would expect that at level 4, it would be able to understand road closure signs and things of that nature. But I don't have specific reports or data that I can point to say that conclusively.
I can probably add a little bit to this. So I recently came across a gentleman who told me that there is in Michigan, there is tests going on, and I'm not sure who the provider is, but what they're doing is that they're putting out QR codes that are especially for construction projects. And the idea is that since there are scanners on the car, the intention is that the car will read the QR code, send it online, and there is a mechanism, I guess, or there's supposed to be one in place that checks the validity of that QR code. And then I guess the car might be able to download the detour and other details about the project. But that's something that I can't confirm. I just heard from I forgot the name of the company that told me. It might have been 3M.
And so that's one way. That's it. I haven't heard that, and so I'm curious to go and look that up. And of course, the other aspect would of course be if that construction zone is able to broadcast hey, this is a construction zone, and these are the changed, these are how the lanes have since changed, or these are the new traffic patterns. Then that would be another way for the automated vehicle to understand what's about to happen and basically be able to navigate through that safely.
That's a good point too. So anybody, if you're making a car or putting some smart construction zones, here's your $1 million opportunity. The next question we have is Transport Canada working with Senate to revise the Bill S2 to allow import of vehicles without steering wheel in Canada? And that's like the Navia shuttle.
Yeah, so Bill S2, it passed the Senate, I believe. So I'm from the program side. That's a regulatory question. The idea behind S2 is that it would amend the Motor Vehicle Safety Act to make it easier for the minister to apply exemptions to some of the regulatory requirements. Mm-hmm. So I think the answer, generally speaking, is yes. It would make it easier to import vehicles for, certainly for testing purposes or whatever else. But it hasn't gone through, from memory, it's passed Senate, but it hasn't passed the House yet.
Okay. The other question, Ken, is what AV training opportunities are available through Transport Canada for interested individuals, road authorities, and transportation professionals, aside from webinars?
Perhaps I don't follow. What does that mean, AV training?
Yeah, I think that's maybe. I don't know. I'm not sure if the gentleman.
In context of, let's say, how road authority, training to help road authorities prepare for AVs. Is it if?
Yeah, I think.
I'll tell you what. I welcome whoever asked that question. You've got my email address. Please feel free to contact me directly. I may not have a great answer for you, but don't hesitate.
What if it was for municipalities? What do you have something in place for municipalities? In terms
of training, okay. So I'm going to go back a couple of here. That whole training and education piece. Do we have anything right now? No. Do we recognize that it's an important piece? Yes. To once again, look to our colleagues in the States. One thing that's super interesting that they did is there's something called the Consortium for ITS Training and Education. And, they've got a whole bunch of online courses that, US DOT has made available to subnational jurisdictions to take those courses online and make it easy for people to sign up for them by removing the cost. So those are the kinds of things that, hey, can we do things like that? Can we support training and education? It wouldn't be, Transport Canada developing those training courses directly, but I can, part of the ACATS program is seeing, okay, what kind of training is needed and how can we support it?
Understood.
So I'll just say again to the individual who asked that question, if you have ideas on how we can work together, again, send me an email. Certainly, we want to leverage the existing, organizations like the Transportation Association of Canada, like ITS Canada. So feel free to contact me with your ideas.
All right. The next question is, how are municipalities to proactively plan road construction or reconstruction activities to account for CVAVs? That's a broad one.
So I wonder if that's kind of pointing to, adapting roads to AVs kind of longer term. I'm going to assume that's the question. It's interesting. I went to SAE World Congress 2015. And at the time, they were saying, the vehicle manufacturers and some of the tier 1 suppliers like Continental were saying, if only you people kept your roads, if we had one wish, it would be that the roads were, without potholes and that the lanes were clearly marked, because it's really difficult for our camera systems to read lane markings when they're kind of, faded. And over the last few years, you've heard a little bit less of that, where the vehicles seem to be, and the vehicle manufacturers are really making an effort to design the vehicles based on the configurations of, and the realities of roads today, because it's easy for a vehicle supplier to say, hey, fix your roads, when they're not the ones paying for it. So one particular project, though, there may end up having to be some kind of a balance. And one project that TRB has on the go is around lane markings and different kinds of lane markings for vision-based systems. So if you look that up, perhaps that'll help also answer, perhaps in some of the reports, that might help answer some of the questions around, planning roadways for automated vehicles.
Does Transport Canada have any plans to assist municipalities through seed funding to conduct a gap analysis of resources, technologies, and what we need to help us move forward?
Okay, so something I guess I forgot to mention is, with the ACATS program, we had a call for proposals for projects, relating to connectivity, automation, cybersecurity, digital infrastructure, and those three areas of work. So, what I'm hearing is this, even this kind of gap analysis, we did have a call for proposals. It closed November 30th. Again, saying it's a modest program, we had $1.7 million available to support projects. We received way more requests for funding than what was available. It is, and the projects would start April 1, 2018. So it is the intention to announce, pardon me, to make the decisions on the final projects, by the end of this month. So in the short term, no. There's, let's see how these first sets of projects that, in some cases will maybe answer some of these questions, kind of, get started. But then we'll kind of look again at the need and what else we can do and how else we can support individual projects. But we've got, our call for proposals, did close in November. All
right. Thank you, Ken. We hit the clock right at 2:30 now, so I'm going to stop answering questions from you. But thank you once again. Really appreciate it. And I'm hoping that this is the beginning of our discussions. We'll continue forward. And thank you once again. Really appreciate it.
All right. Thank you for inviting me. Have a good afternoon.
Take care, Ken. Bye.
Bye.